Hello friends, welcome to this lecture of Fuzzy Logic. I am Professor R.V. Kolle, Assistant Professor from Civil Engineering Department of Sanjeevani College of Engineering, Kopargaon. So welcome to the first lecture of this Fuzzy Logic. This lecture basically based on the introduction of fuzzy logic, then little bit introduction of artificial intelligence, and I will try to here relate fuzzy logic with artificial intelligence. So before I move to the part, I would like to tell you that fuzzy logic is a multi-valued logic of the course, and as I have mentioned already that there is a linkages of fuzzy system with artificial intelligence. So, in other words, I would like to tell you that the fuzzy system is one of the best key agents of artificial intelligence. So, when we talk about artificial intelligence or machine intelligence, in other words, let me briefly define what is artificial intelligence. So, artificial intelligence is nothing but it is an discipline which involves all sorts of mechanisms, algorithms that deals with mimicking the activities of our brain. If you think of the, I would like to also go through the brief history of the artificial intelligence since we are going to the finally to study fuzzy systems, and I has mentioned over here the linkages of fuzzy system with artificial intelligence. So it is necessary to have our brief history of artificial intelligence. So artificial intelligence starts with the Allen's universal Turing machine. It is here, it was the time in 1936 to 37. So around it was proposed, and it is the beginning of the artificial intelligence. It is seen here in 1942 43. The Warren and the Walter Pitts created computational model for neural networks, and that was also called as threshold logic. So this was the time when artificial neural network started. So here it was basically a you can say it's a preposition of ANN model, and it was based on the biological neuron. Then in 1950 a Turing test was performed. In 1955 the formal name artificial intelligence has come up. So this name was given by John McCarthy, and as it's written here in 1955, John McCarthy, founding the father of artificial intelligence, he has coined the artificial intelligence. In 1957, the you can say the first model was introduced, and that model is nothing but again it's a artificial neural model. The difference here is just activation function. So the you can say it's the model is based on ANN with activation function binarily linear. So next slide is with artificial intelligence history. In 1960s, the genetic algorithm was proposed, and in 1965, it is very important to note that fuzzy logic was proposed by Professor, you can say Zade, and this is the time when a deep learning term, that is what you can say, it's a very popular term being used nowadays. It's coined in 1965 by Ivancho and Lapa. So I would like to say here, this year we're having the two main concepts we are proposed. First is fuzzy logic, and second one is deep learning, and these two have very high relation. In 1960s, evolutionary computing was proposed, and so various algorithms of evolutionary computing was proposed. In 1990, witnessed neural computing and swarm intelligence. In 1990s, hybrid models of these neurofuzzy systems and fuzzy genetic algorithms like models was proposed. And so, in nutshell, I would like to say that fuzzy neuro genetic all these were together used to better model performance, and these were proposed, then the studies began. Beyond 90s, if you see, the research areas based on all these agents were helpful, giving rise to the various model systems. For example, if systems, evolutionary computing, data mining, then you can say simulated annealing, particle swarm algorithm, deep neural networks, deep fuzzy neural networks. That is what began. Next is the agents of artificial intelligence. So artificial intelligence, which has been started, which it is on the screen. I would like to say it's a birth of artificial intelligence is seen around 1936 to 1937. And you know what? The advent of these all agents, for example, fuzzy systems, neural networks, genetic algorithm, and many more, which I am with describing due course of time. So we can see that these all agents are like fuzzy systems and artificial neural systems, or you can say it's a evolutionary systems. And evolutionary system algorithm are mainly cover genetic algorithms, differential evolutions, and then evolution systems have made heuristic and swarm intelligence. Under these, we have ant colony optimization, bees algorithm, bat algorithm, cuckoo algorithm, harmony search, firefly algorithm, artificial immune system, particle swarm optimization. If you see the agents of artificial intelligence are have probabilistic systems. For example, Bayesian network, Gaussian mixture models, hidden macro models, which are not mentioned here. And we have an agent of AI, that is what artificial intelligence. We have chaos theory, then simulated annealing, rough set theory, then support vector mechanics, then you can sorry machines, and there are many more agents that are mentioned here. See the statement next. Fuzzy system is also one of the key agents of computational intelligence. So, fuzzy system is one of the key agent of artificial neural network and neural science. So, computational intelligence is equivalent name of artificial intelligence. And these two names go hand in hand. I would like to say that just briefly tell you the definition of a computational intelligence. So, what is computational intelligence? So, computational intelligence basically is a set of nature inspired computational methodologies and approaches to address complex real world problems to which conventional mathematical or traditional modeling can't be useless. It can be useless. So, for the reasons the processes might be too complex, processes for which we are developing a model could not be complex for mathematical reasoning. So it might be contain some uncertainties during the process, or the processes might be simply, you can say, stochastic in the nature. So that is why it might contain the, you can say, major components of computational intelligence are fuzzy systems, the neural evolutionary algorithms and other hybrid intelligent systems are there. So we can clearly say here, that is, which is also a key agents of artificial intelligence, which is, I mean here that artificial intelligence and computational intelligence, although these two go hand in hand, being interchangeably being used, and the fuzzy system is a key component of these two. So we see here artificial intelligence, machine learning and deep learning. Just let us now just look at the artificial intelligence, machine learning, deep learning. So at this stage, let us know to understand uh, how this artificial intelligence, which we have just discussed, and machine learning and deep learning, how these three terms are related. So we see here artificial intelligence is a very broad term. So what do I mean by broad term here? It is the term artificial intelligence is a bigger set, and the machine learning is the actually part of artificial intelligence, because the agents of artificial intelligence like fuzzy systems, neural network, artificial neural network, genetic algorithm, and all which all other already I have mentioned. So they help us managing the machine learning process or the machine learning activities. And then comes the deep learning, which is again, if you see here, it's a very smaller set rather than machine learning. So it means that the machine learning is a bigger set, deep learning is a smaller set, uh, and the deep learning contains the machine learning and artificial intelligence, like this. It means that the deep learning is a part of artificial intelligence, and deep learning is a part of also machine learning, and deep learning here would mean that it is a part of machine learning. And in machine learning, when there is an intense learning process, or you can say it's a repetitive learning hierarchy there, then so it is termed as deep learning. In nutshell, I would say that the deep learning is the part of artificial intelligence as machine learning. Let me just briefly describe how artificial intelligence theory getting developed through these various research experts or from various fields. For the example, the statistics, mathematics, engineering, neural sciences, or natural sciences, computational computer sciences, and the artificial intelligence is interdisciplinary area, and the experts from these areas, but not limited to these areas, they are contributing to the theory development of the artificial intelligence. And if we see here, the artificial intelligence is used by various fields. For example, computer vision, and we see here the natural language processing, information retrieval information, then predictive analysis, decision analysis, robotics. And these are not limited to these. Again, these are few fields, these are few fields mentioned here, and that many more where artificial intelligence is contributing. And if we see here, they are separate applications again, and I would like to say these applications are the applications that are mentioned here are only few applications, but there are many more applications in the respective field are being practiced, which are being carried out by various departments of artificial intelligence. So now, coming to the fuzzy system, the fuzzy system theory is based on fuzzy logic. Professor Lotfi A. Zadeh, which is who you can say it's known as father of fuzzy system, and he proposed the idea of fuzzy logic in 1965. Fuzzy system theories differs from conventional computing because the conventional computing is based on bivalent logic, or you can say it's a Boolean logic, uh, that you can know. Whereas fuzzy logic is based on the multi-valued logic. It is not based on single or binary logic or Boolean logic. It's multi-valued logic. So we can say that the conventional computing is based on one of the cases that we can say that the conventional computing that we have done, it is the set of that multivalent logic. So far, one of the cases of fuzzy logic, or you can say mathematic based to the fuzzy logic. Fuzzy systems, that theory involves the soft or partial truth or partial false, or soft because truth, it is soft, it is means that it is a true. You can say, but not it is 100% true. Somewhere in between 0 to 100% false, or in between 0 to 10%. So it is the 100% true, that it is hard to have false, it's 100%. It means that false is hard. But if there is a truth, or there is a false which is not 100%, or somewhere it is in between 0 to 100%, it is termed as soft. So, fuzzy system theory also deals with uncertainties, ambiguity, imprecision, and the vagueness. So, these are the uncertainties which are very special kind of uncertainties, because these uncertainties cannot be dealt with other artificial intelligent agents. So far, we have done mainly basically uncertainties due to the randomness, and which is can be dealt with the probability theory, because uncertainty here it is due to the randomness. So it is that this theory is different from uncertainties due to randomness, and so that is why fuzzy system theory as well suited for tackling these uncertainties. And let me make it clear that what is uncertainty. it cannot be dealt with the probability theory as well. And you can, another thing, there is fuzzy system theory is multidisciplinary areas. Multidisciplinary area would mean that the concept of fuzzy system theory can be very well utilized by many disciplines. As for example, in engineering sciences or humanities or so on, as I already mentioned that the fuzzy system theory is based on the fuzzy logic, and fuzzy logic is multivalent logic. So already I explained that difference between the bivalent logic is nothing but the Boolean logic and the multivalent logic. So let us know that to understand in bivalent logic truth, the bivalent means every proposition is either true or a false with no degree of truth allowed. Means that truth is truth and false is hard. In multivalent logic, as already explained, this truth is matter of degree, and I would like to say that I mentioned just before the slide, the truth or the false is soft. A multivalent logic can be multivalent logic as the value of truth or false, they can be having any value between 0 and 1. So that is why if we talk about the degree, so degree can be infinite number, the number of values can be assigned to the infinite. So fuzzy logic deals with the partial, which is a matter of degree. So partial performance, or you can say imprecise information fuzzy logic deals with the granular information. Granular theory over here, it would like to mean that we have linguistic information based on the fuzzy logic can be deal with this kind of information, and to manage to quantify from the linguistic information, and fuzzy logic can be helpful for perception based information. In other words, the perception based information can be quantified by fuzzy logic. Let me go through the historical background of the fuzzy logic. The classical logic or Aristotle that proposed in 400 BC before Christ. So now it is very clear that the bivalent logic or the Boolean logic was developed by Aristotle in 400 BC. The law of bivalence, which is used for more than 2000 years. So it means very proposition in, you can say it is in false or it is true. It is means that true here it is hard and false is also hard. Means that 100% true or 100% false. So there is no intermediate value of the truth or false. So in other logic, it was developed by Jan, who has proposed this three value logic in 1900 AD after the death of Christ. This logic is, you can say, three valued logic. It means we have true, we have false, we have possible. And that Professor Zade proposed fuzzy logic in 1965, which is bivalent logic, and this is again very popularly known as fuzzy logic. So what is fuzzy system theory? So fuzzy system logic or fuzzy logic is much more general, as already mentioned here. It is than the, you can say, traditional logic or conventional logic, this system based traditional logic system. So I can say that the traditional logic system, it is, you can say it is fuzzy logic, and this is much more general than the traditional logic system. Fuzzy logic provides a foundation for development of new tools for natural language processing like computing with the words. So it is very important area where fuzzy logic is very helpful. In other words, fuzzy logic has ability to deal with, uh, you can say, ability to deal with the, to understand the linguistic information, to quantify in such a way that linguistic information is properly understood and it can be processed and can have suitable output. Okay, so next, what is Boolean theory? The Aristotle came up with the binary logic, which has been principal foundation of conventional mathematics. and the Boolean logic states a glass can be full or not full. So if we have case for example that a glass is either halfway filled, so by using Boolean logic we cannot manage to define the half full glass of water or anything. So this disproves the Aristotle's law of biological logic. In other words, we can say that the Boolean logic is not sufficient to manage to take up the kind of situation. This concept of degree of multivalence is fundamental concept. It has been stated by Lotfi Zade and it helps in defining such situations as well. So, basis on which fuzzy logic was proposed, here the complexity of the system increases. It becomes more difficult. Eventually, the you can say it is very impossible to mean that to counteract the fuzzy logic. So, Professor Lotfi Zadeh claimed that in many sets of the world surrounding by which it can be defined, it can be a distinct boundary. So we will have few examples later and then we'll see that the claim of Professor Zade is true. And let us also understand, let us know why we should use fuzzy logic or fuzzy system theory. So the fuzzy logic or fuzzy system, when we have systems with uncertainty due to the imprecision, I mean the theory of systems which suffers from the uncertainty, it is due to the imprecision or it is due to the vagueness, ambiguity, randomness, or partial truth or approximation. Fuzzy logic can be very useful in managing with the black box model or gray box model of the system. Many times we do not have that idea of exact physical laws of system defining or defining the system, or many times the system which we are studying are trying to model that it is not accessible to us. So we do not have that physical laws which are governing the system in order to model or to have system mathematical. So we cannot get the exact mathematical equations. So when this situation occurs, we have to take help of black box modeling, where fuzzy system is also one of the tool, one of the agent, one of the method we can manage, and we can have the model system with black box modeling approach, or the you can say gray box modeling approach. So when we say that gray box means that part of system's mathematical equation are known, or either known can be known, that that the system can be used for fuzzy logic or fuzzy system theory in order to get the final model. So when we should not use the fuzzy logic, this is important. When we should not use the fuzzy logic, like whenever we are already having the physics of the model known, obviously we can have the mathematical equations known. It means we have model available with mathematical model, and the mathematical model, of course, the kind of model which is termed as white box, means the mathematical equations governing the model is known. So we do not require such agents like fuzzy systems or theory or fuzzy based theory go through this black box modeling approach. So in this case the model is completely known as fuzzy logic and not needed. And then here we have a system which is linear system. Then also we do not need to focus on the systems, that theory, for understanding the behavior of getting the model. And the system which moderate the non-linearness, we can use simple models, and fuzzy logic is not needed. Also the systems with moderate complexities, so unless we have very high complexity, we should not use fuzzy systems theory for studying such models. So with this I would like to stop here, and in next lecture we'll discuss some real applications of fuzzy systems. Thank you.